In this video, we're going to cover the following basic differentiation rules. So we have the constant rule, wherein the derivative of a constant is 0. And we're going to cover also the power rule. If we have y is equal to x raised to n, then the derivative is nx raised to n minus 1. And then we're going to show some examples on how we apply constant multiple rule and also the sum rule. So let us have some examples. So let's say we'd like to get the derivative of 6. Since 6 is a constant, the derivative is equal to 0. But if you would like to show the solution, this would be the derivative of y with respect to x is equal to, and then we're going to use this derivative operator. So the derivative of y with respect to x is 0. Y is equal to x cubed. So doing this, we have the derivative of y with respect to x is equal to, so again, let's use this derivative operator to get the derivative of x cubed. So by power rule, we're going to have 3 for the exponent of your x here, and then x raised to 3 minus 1. Simplifying, we have 3x raised to 3 minus 1 is 2. This is an example for us to apply the constant multiple rule. So for this case, let's say we would like to get the derivative of the given function. So by constant multiple rule, we're just going to have 2 times the derivative of x raised to 4. Solving this, we have 2 times the derivative of x raised to 4 by power rule is 4x raised to 4 minus 1. Or we have 2 times 4 is 8, x, 4 minus 1 is 3. Let's say we have y is equal to 3x squared plus 2x minus 5. For this function, we're going to get the derivative of each term. So we're going to apply the sum rule. So we have the derivative of y with respect to x is equal to, so let us get the derivative of each term. So for the first term, we're going to have the constant multiple rule. Same with the second term. So we have 3, and then the derivative of x squared is 2x raised to 2 minus 1 plus 2. The derivative of x is x raised to 1 minus 1 minus 0. So to simplify, 3 by 2 is 6, x raised to 1 plus 2x raised to 0, and x raised to 0 is equal to 1. Therefore, the derivative of the given function is 6x plus 2. Let's say we have y is equal to 5 over x. If this would be the case, we can rewrite this as y is equal to 5x raised to negative 1. So that we can apply power rule to x raised to negative 1. So if we would like to get the derivative of the given function, we have 5 and then the derivative of x raised to 1. Therefore, this would be 5 times the derivative of x raised to 1 by power rule is negative 1, x raised to negative 1 minus 1. Therefore, that would be 5 times negative 1 is negative 5, x raised to negative 2. So to simplify, this would be negative 5 over x squared. Another example, we have y is equal to the square root of x. To apply the power rule, we can write this as y is equal to x raised to 1/2. And getting the derivative, we have the derivative of x raised to 1 half. And we have, by power rule, that would be 1 half times x raised to 1 half minus 1. So this would be 1 half x. 1 half minus 1 is negative 1 half. Simplifying, we can write this as 1 half times 1 over x raised to 1 half. And 1 times 1 is 1 over 2. And x raised to 1 half is square root of x. Let's say we have y is equal to 3x raised to negative 2 plus 1 over x squared plus 6. So the derivative of this is equal to, so let's use the derivative operator, 3, and then the derivative of x raised to negative 2 plus 1 over x squared can be written as x raised to negative 2. So this would be x raised to negative 2 plus the derivative of 6. So we have 3 times the derivative of x raised to negative 2 is negative 2, x raised to negative 2 minus 1, plus x raised to negative 2 would be negative 2, x raised to negative 2 minus 1, and then the derivative of 6 is 0. To simplify, we have 3 by negative 2 is negative 6, x, negative 2 minus 1 is negative 3. This would be negative 2, x raised to negative 3. So we have negative 8x raised to negative 3. Simplifying, this would be negative 8 over x raised to 3. Let's say we have y is equal to 2 over x raised to 4 plus x minus 7. So this can be written as y is equal to 2 x raised to negative 4 plus x minus 7. Getting the derivative, we have 2 times the derivative of x raised to negative 4 plus the derivative of x minus the derivative of 7. So this would be 2 times the derivative of x raised to negative 4 is negative 4, x raised to negative 4 minus 1, plus this would be x raised to 1 minus 1, and then the derivative of 7 is 0. Simplifying, we have negative 8, x raised to negative 5, plus x raised to 0. So x raised to 0 is equal to 1. Simplifying, we have negative 8 over x raised to 5 plus 1. In this video, we're going to cover product rule for derivatives. So if we would like to get the derivative of the product of g of x and h of x, that would be g of x times the derivative of h of x plus h of x times the derivative of g of x. So let us answer some examples. Let's say we have the product of x plus 3 and x minus 5. So if we would like to get the derivative of this function, so let's say x plus 3, this is our g of x, and x minus 5, this is our h of x. So again, to get the derivative of this function using product rule, we have g of x times h prime of x plus h of x times the derivative of g of x. So g of x is x plus 3 times the derivative of x minus 5 plus x minus 5 times the derivative of x plus 3. So we have x plus 3. The derivative of x minus 5 is 1 plus x minus 5 times the derivative of x plus 3 is 1 plus 0, so it's just 1. Simplifying, x plus 3 times 1 is simply x plus 3, and x minus 5 times 1 is x minus 5. So we have x plus x is 2x, and 3 minus 5 is negative 2. So let's say we have the product of 3x minus 2 and x squared plus 7. So again, we have g and then the derivative of h plus h times the derivative of g for our product rule. So to get the derivative, we have 3x minus 2 times the derivative of x squared plus 7 plus x squared plus 7 times the derivative of 3x minus 2. So getting the derivative of x squared plus 7 is 2x plus, so we have x squared plus 7. The derivative of 3x minus 2 is 3. And then 3x minus 2 by 2x, we have 6x squared minus 4x plus, so we have x squared plus 7 times 3. So that would be 3x squared plus 21. So we need to multiply 3 to x squared and 7. Simplifying, 6x squared plus 3x squared is 9x squared, and then minus 4x plus 21. So this is the derivative of the given function. For this example, the derivative would be 4x times the derivative of 6x squared minus 3x minus 1 plus 6x squared minus 3x minus 1 times the derivative of 4x. So we have 4x times the derivative of 6x squared is 12x, negative 3x is negative 3, and negative 1 is 0. Plus, so we just have to copy 6x squared minus 3x minus 1, and the derivative of 4x is 4. Multiplying 4x by 12x minus 3, we have 48x squared minus 12x plus 4 times 6x squared is 24x squared. 4 times negative 3x is negative 12x, and then minus 4. So to simplify, 48x squared plus 24x squared is 72x squared. And then negative 12x minus 12x is negative 24x and minus 4. So this is the derivative of the given function. Okay, for this example, let's say this is our g of x, and this would be our h of x. So we have g h prime plus h g prime. To get the derivative, we have g of x, that would be x squared plus 7x minus 2, and then the derivative of 2x plus 1 plus 2x plus 1, and the derivative of x squared plus 7x minus 2. So let us copy x squared plus 7x minus 2, and getting the derivative of 2x plus 1 is 2 plus, so we have to copy 2x plus 1, and the derivative of x squared is 2x. For 7x is 7, and negative 2 is 0. So we need to multiply 2 to our trinomial here. So we have 2x squared plus 14x minus 4. So for the product of these two binomials, we have 2x times 2x is 4x squared. 1 times 2x is 2x. 2x times 7 is 14x. And 1 times 7 is 7. So combining like terms, we have 2x squared plus 4x squared. So that would be 6x squared. And then 14x plus 2x plus 14x, that would be 30x. And negative 4 plus 7 is positive 3. So that would be the derivative of this function. In this video, we're going to cover quotient rule for derivatives. So if you would like to get the derivative of f of x over g of x, that would be g of x times the derivative of f of x minus f of x times the derivative of g of x over the square of g of x. So in this case, since multiplication is commutative, we can have f prime of x times g of x minus g prime of x times f of x. But what we cannot do here is to have f of x times g prime of x minus g of x times f prime of x. So let us have some examples. So let's say we have 2x minus 1 over 3x plus 2. Let's say this is f of x, and this one would be g of x. Let us be guided by our formula here. So to get the derivative of the given function, we have g of x is 3x plus 2 times the derivative of 2x minus 1 minus f of x is 2x minus 1 times the derivative of 3x plus 2 over the square of our denominator. So the derivative of y is equal to 3x plus 2, and then the derivative of 2x minus 1 is 2. So this would be 2 minus, let us copy 2x minus 1, and the derivative of 3x plus 2 is 3 over the square of 3x plus 2. Now, we're going to multiply 2 by 3x plus 2, and then here 3 times the negative of 2x minus 1. So that would be 6x plus 4 minus 6x plus 3 over 3x plus 2 then square. So remember here that we need to multiply negative 1 to the product of 2x minus 1 and 3. So to simplify, 6x minus 6x is 0, and then we have 4 plus 3, which is 7, over the square of 3x plus 2. So this is now the derivative of the given function. So let us have another example. Let's say we have x squared minus 2x over x squared plus 4x minus 1. So again, this is our f of x, and this is g of x. So to get the derivative, this would be x squared plus 4x minus 1 times the derivative of x squared minus 2x minus x squared minus 2x, or our f of x, times the derivative of x squared plus 4x minus 1 over the square of x squared plus 4x minus 1. So let us get the derivative of f of x and g of x. Here we have x squared plus 4x minus 1. The derivative of x squared minus 2x is 2x minus 2 minus, so let us copy x squared minus 2x. The derivative of x squared plus 4x minus 1 is 2x plus 4 over x squared plus 4x minus 1 squared. So to continue, we're going to multiply x squared plus 4x minus 1 by 2x minus 2. And then here, we need to multiply x squared minus 2x by 2x plus 4. And do not forget to multiply negative 1 to the product. So let us have 2x cubed minus 2x squared plus 8x squared minus 8x, and then we have negative 2x plus 2. X squared times 2x is 2x cubed times negative 1 is negative 2x cubed. X squared times 4 is 4x squared times negative 1 is negative 4x squared. Negative 2x times 2x is negative 4x squared times negative is positive 4x squared. And negative 2x times 4 is negative 8x times negative 1 here is positive 8x over our denominator. Simplifying, we can cancel some terms. So we can cancel 2x cubed, 8x here, and 4x squared. So what we have would be negative 2x squared plus 8x squared minus 2x plus 2. So if we simplify, that would be 6x squared minus 2x plus 2 over the square of x squared plus 4x minus 1. So this is now the derivative of the given function. So if you would like to get the derivative of a composite function, meaning we have a function inside a function. So we would be having the derivative of the outside function leaving the inside function times the derivative of the inside function. So let us have some examples. Let's say we would like to get the derivative of y is equal to the fourth power of 2x plus 3. So in this case, our inside function is 2x plus 3. First, we need to get the derivative of the outside function, leaving the inside function, meaning we still have 2x plus 3. And then we're going to get the derivative by using power rule. So this would be 4, and then the exponent would be 4 minus 1. And then multiply to the derivative of the inside function, which is 2x plus 3. So the derivative would be 4, and then we have 2x plus 3 raised to 3. The derivative of 2x plus 3 is 2. To simplify, we have 4 times 2, and that would be 8. And we have 2x plus 3 raised to 3. So this is the derivative of the fourth power of 2x plus 3. For this example, for us to get the derivative, again, the derivative of the outside function leaving the inside function. So for us to get the derivative of this function, let us copy 3. And then for power rule, leaving the inside function, which is x squared plus 2x minus 5. So I have 5. And then for the exponent, we have 5 minus 1. And then get the derivative of the inside function. To continue, 3 by 5 is 15. And then we have x squared plus 2x minus 5 raised to 4. And the derivative of the inside function is 2x plus 2. To simplify, we can multiply 15 to this binomial. So we have 15 by 2x is 30x. And then 15 by 2, that would be 30. And then times the fourth power of x squared plus 2x minus 5. So this is now the derivative for this example. So to get the derivative of this function, let us have negative 2. If it's negative 2x, we are going to consider the product rule for our process. Since it's just negative 2, we are looking at this following the constant multiple rule. So for this part, we would be having 7 times the inside function, which is 2x cubed minus 7x squared plus x plus 9. We have 7 minus 1. And we need to get the derivative of the inside function. To continue, we have negative 14. So this would be raised to 6. And then the derivative of the inside function is 6x squared minus 14x plus 1. So we have negative 84x squared plus 196x minus 14, and let us just copy this factor. So this is now the derivative of the given function.